right, welcome and thanks for joining 6.1 examples. We are on the fourth slide. Use the law of sines to solve the triangle if A is equal to 36 degrees, side A is equal to 8, and side B is equal to 5. So I drew a picture there for you. Where you place A, B, and C, not as particularly important, but keep in mind that A is an acute angle. First thing I'm going to do is just check, when I look at this, I see side, and a non-interior angle. So side angle, ambiguous case. I'm going to check the height of this, or actually I'm going to check first A and B. So this is an acute angle, and the side across from the angle, A, is greater than the other side given, B. In this case, there's always one triangle. So I don't have to worry about that two triangle scenario. And, there's my evidence. So if I'm solving this, I'm just going to call this side C. First thing that I'm going to look at is the fact that this A is the part that I have corresponding. So I would say A over sine 36 is equal to, and it doesn't matter, actually it does matter in this case, we have to solve for B first. We don't know anything about C, but we know that B is 5. So then I'm going to solve for sine B. In this case, cross multiplying and everything, I get sine B is equal to 5 sine 36 all over 8. And then this is where I do inverse sine. So B is equal to inverse sine of 5 sine 36 over 8. And that gives me B as approximately 553 degrees. Once I know angle B, I can find angle C by doing 180 minus angle A, which is 36, minus angle B, which is 21.553. I get angle C as being approximately 122.447 degrees. And now knowing angle C, I can solve for side C. I always start with this same thing, 8 over sine 36. But now it's equal to the ratio for C. So C over the sine of 122.447. So C is equal to 8 sine 122.447 over sine 36. And I get C is approximately 11.486. So there we go, one triangle I solved for all the missing pieces. Looking at some other examples, just talking about the ambiguous case. Now I put in the answers for you, but let's just act like they're not there. You can't see them. I have A being 110 degrees. So this is an obtuse triangle. In an obtuse triangle, the side across from the obtuse angle has to be the largest side. And the side across from the obtuse angle, side A, is actually less than side B, which means there's no triangle. In this next case, I have an acute triangle or an acute angle. So this is the case where I don't know, there's so much that could be happening. So first, I see that A is less than B. When I know that A is less than B, that does give me a little bit of information, because A being less than B means that I do not have an acute case. And I'm sorry, I do not have a no triangle case. So I'm either looking at one or two triangles. If I want to find out, I have to solve for H. So I have H equals B sine A. So H equals 18 sine 45, which gives me 18 root 2 over 2. So 9 root 2. 9 root 2 is, I don't know, I want to say it's like 12 point something. But what I do know is that it's less than 14. So since we have a case where the side across from the acute angle is somewhere between the other side given and the height of the triangle, there are two solutions. Two triangles. We don't really need the apostrophe there. or two solutions. So again, because that side across from the acute angle is between H and the other side given, I have two triangles. All right, so moving on, another law of sines question. You can see here there's two triangles, but I'm just going to go through the, actually, it's the same problem. So here are those two triangles. What we're going to do now is actually solve for all that information. So looking at this, I'm just going to call this B sub 1, C sub 1, and C sub 1. Looking at this, what I told you is when you have side, and sorry, my angle's over here, non-interior angle. The angle that you need to solve for first needs to be the non-interior angle. So here we have side, angle. So I need to not solve for angle C and solve for angle B first. So I'm going to solve for B sub 1. And your reason is because B sub 1 is the one that it might be or obtuse here and might be acute here. So actually, I'm going to do something really, really annoying. I'm going to get rid of these. And I know as a fact that I'm solving for this triangle first. Now you might be thinking like, whoa, tricky devil, how did you know that? Remember that if I'm going to eventually do the inverse sine for this, and that's only going to give me an acute angle. So there's no chance that I'm solving for this one first because that's obtuse, just the way that I drew it. So if I'm going to solve for this first, I'm going to set up our ratio 14 over sine 45 is equal to 18 over sine of angle B1. Solving this, I get sine of B sub 1 is equal to 18 sine 45 over 14. And you do inverse sine. So B sub 1 equals inverse sine of 18 sine 45 over 14. And you get B sub 1 as approximately 65.386 degrees. Now this is asking for me to solve the whole triangle, so I actually have to go and solve for the C as well. Angle C sub 1 is equal to 180 minus 45 minus 65.386, which gives me approximately 69.614 degrees for angle C1. And then I'll use this same start, 14 over sine 45 equals little c sub 1, side c sub 1, over the sine of 69.614. When I solve that, I get c sub 1 is approximately 18.559. Okay, so cool. I did this problem, but there's actually, a whole other set of solutions. If I'm going to solve for b sub 2, c sub 2, and little c sub 2, I need to solve for angle b sub 2 first. And I do that by doing b sub 2 equals 180 minus b sub 1. So b sub 2 is approximately 114.614 degrees. And again, just thinking about this, 114 plus 45 is going to give me 159. So this angle can exist, which means there definitely is a second triangle. If it was something larger than 180 when I added these two, there'd be an issue. C sub 2 equals 180 minus 45 minus 114.614. I would get angle C sub 2 being approximately 20.386. And again, if you thought there were two triangles and you did this, you would get some negative here. And you'd be like, maybe that doesn't make sense. Last step, we're just really redoing this, but with a different sine value. So we're going to have 14 over sine 45 equals c sub 2 over the sine of angle c sub 2. This gives me side C sub 2 being equal to 6.897. All right, so that's solving like that whole ambiguous case where you have two triangles. It is a lot of work. I'm not at all going to disagree with you in that. But the wonderful thing about it is generally speaking pretty easy work. And where most of honors pre-calc is not easy work, you really want to like take hold of this easy moment that, yeah, it's just a little bit tedious, but is breezy to get through. So last, find the area of a triangle with the given dimensions, B being 130 degrees, side A being 92, and side C being 30. So the formula that we use here is area is equal to 1/2 the two sides, so A times C, times the sine of the angle. So that gives me A equals 1/2 92 times 30 times the sine of 130 degrees. That gives me, if I just shoot that into calculator, area is approximately 1057.141. We don't have the unit of measurement, but it's just units squared. All right, that's it for 6.1. Again, 6.1 should be pretty fine for you to get through, just some of those cases where it might be something ambiguous. Do pay attention to things like rounding, and if you need help, just ask about how to like put things in a calculator and such things. Good luck.